Okay, so for the Unit 4 distributed practice review, I'm going to go ahead and go over the 4 questions that you'll have to know about. So the first one is about the inverse, and the inverse is when you switch your x and your y. So the first thing I'm going to do is I'm going to rewrite this f of x so that it's a y. And then I'm going to switch them. So I'm going to change colors so you can see that there was a switch. So the x goes here and the y goes in this spot. And then everything else stays exactly where it's at. So the equal sign, the third root, the -1, and the +5. Then we have to try to solve for y, try to get y by itself. So y is inside of this cube root, so we can't touch it. So we have to look on the outside to see if there's anything we can get rid of, and there is. There's this +5. So I have to subtract 5 and subtract 5 from over here. So this is x minus 5 equals the third root of y minus 1. Now we want to try to get the y minus 1 out of there, so we can use an exponent to get that to cancel, and then we're going to do that to the other side as well. So that 3 cancels out the cube root, so now y minus 1 is kind of out of there, it's kind of free. We have x minus 5, and with these exponents on this type of problem, you don't actually have to like multiply it out. Unless you look at a multiple choice test and it doesn't have parentheses anymore, but for the most part, we kind of just leave them as is when we're doing these inverses. Then we're going to add 1 to get the y completely alone. Now that 5 isn't really a 5, it's a 5 to the third power, so I can't add that with the 1. So all I do is copy this down, x minus 5 to the third power, and put the +1 at the end, and then this is what y is. Now technically, this is the answer, but technically you're supposed to change it back to f of x, but we have to put this little -1 up here to show that it's not the original problem, but it's the inverse. So this is going to say x minus 5 in the parentheses to the third power +1, and then that's our final answer. Okay, number 19. Number 19 is basically a calculator question. You can tell because this has a number inside. So anytime there's a number inside, you want to start with the problem that's closest to it. So we're going to start with the g problem. So the g problem is g of -2 is equal to 1/4 times -2 minus 3. So I'm going to pull out my calculator, go into the regular calculator, and let's get rid of this. So I'm going to put 1/2, 1/2, parentheses, -2, and then minus 3. So that tells me that the answer is -4. Now that's not my final answer, that's just the first step. So now we know that this answer here is 4, so now we put 4 into f. So now for my f function, my f problem is f of -4 equals -2 squared plus 5. This one has 2 different x's, so we have to make sure to put 2 different parentheses. And then we're going to stick the -4 in there. So -4 goes here, and -4 goes there. And again, it's just a calculator question. So we can do -2, so -2, parentheses, -4. And that's going to be to the second power, so squared, plus 5, and then parentheses, -4. So the final answer is -52. Okay, next is a factoring question. Remember that when we factor, there's a couple of patterns that you have to remember. You have to remember the difference of squares and then the difference of cubes. I'll probably have those up on the board when you take the test, so you don't have to like memorize them or anything. And then any of the ABC problems, we know those can be done in the calculator. So we don't have an ABC problem here because there's only 2 terms. So that means it either has to be a squares or a cubes problem. Now there's some hints in this question. There's some things in here that tell us which one it is, specifically this x to the third. That third tells us that it's the cubes pattern. Now if you don't remember the cubes pattern, it goes like this. It's going to be A, B, A times A times B, and then B times B. And then for the signs, we use the SOAP acronym. So this one should be the same, this one should be opposite, and this one should be always positive. So to come up with the first two terms, we have to cube root this. So I'm going to cube root this, and that's going to give me the x. I'm going to cube root this. So we'll do cube root. So in the calculator, the cube root is shift, and then to the right of the x squared button. That'll allow us to put the little 3 up there. And I want to put in the 1000. So that answer is just 10. So this is going to be 10. Now I'm not going to put any signs here because I'm going to do those at the very, very end. So now I'm going to use this to build my other answer. So my other answer is going to be, let's see, let me put this in red so I can follow the pattern. So this would be the A and this would be the B. So following this pattern, A times A would be x times x. So this would be x squared. Then following the pattern, A times B would be x times 10. So that's going to be 10x. And then if we follow the pattern for this last spot, it's B times B. So 10 times 10 is 100. And then we use the acronym SOAP. S means the same. So the same is this one right here. So we just drop that one down. So that's going to be a minus. O stands for opposite. So the opposite of minus is plus. And then the last one on all the problems for these cubes, this last one is always plus. So it's always going to be positive. So that's our answer. And then the last one talks about the domain. Oh, you know what? Let me just remind you what the other pattern was. The other pattern is called the difference of squares. So that one looks like this, a squared minus b squared. So when we do this one works out to be AB and AB. One is a plus and then one is a minus. I'll do a quick example with one of those. So if I had a squared minus 100. If I have a squared minus 100, notice how it's got the 2. So these are going to be the same size. We square root that and we square root that. So that's going to be a and 10. According to the pattern, these have to match. So I'm going to put a and 10 in this one, and then one has to be a plus and then one has to be a minus. So that's how the difference of squares works. If you have an ABC problem, you can just use your solver, get the answers, and then flip your signs. And if they have fractions, you just have to do bottoms up. Okay, now the final question. The final question says, given f of x is equal to x minus 3 squared, what is the domain of f of x? So you have to know what domain is. So when it comes to domain and range, the domain is going to be your x values. So x I'm going to put this from left to right. Range is the opposite. So range is the y values from the bottom to the top. Now the reason why they have to go like this is because the answer has to be in order. So the x-axis, if you go from left to right, is smallest to biggest, and the y-axis from bottom to top is smallest to biggest. Now, there's a couple of ways you can do this problem. You can either memorize a couple things. So everything has a domain of negative infinity to infinity except fractions. So if you see a fraction, you have to set the bottom equal to 0 and solve. And those are actually your bad answers. So once you find the value of x, that's what x is not allowed to be. So when you write your domain for this, it would say negative infinity to that bad number, union the bad number until infinity. So this is what your answer would look like if you had a fraction, but there are no fractions. The second type of problem is when you have a square root. And it specifically has to be a square root. It can't be a cube root. If you have a square root, let me put this as root. If you have a square root, you set insides. So inside greater than or equal to 0. So that means if I had a problem that said square root of x plus 2, then I would take x plus 2 and set that bigger than or equal to 0. And this works with any number. It doesn't matter. We just subtract 2 as if that were an equal sign. So that's going to be negative 2. So then the domain for this on these square roots is always going to have a bracket. The farthest to the left, or the smallest number it can be, is -2, and then it goes right forever. So these ones are always written like this. Now, if you go back to this problem, it doesn't have any of that stuff. So anytime a problem doesn't have the fraction and it doesn't have the square root, the answer is automatically going to be -infinity to infinity. Now, if that doesn't work for you, you can always look at the graph. So I can go over to the graph and I can type in x, let me delete these. I think it was x minus 3. Let's look just to make sure. Yeah, x minus 3. So I'll put parentheses x minus 3 squared. And then when I look at the picture, I get a picture that looks like this. So the domain from a picture is how far to the left is it going to go and how far to the right is it going to go. Well, even though this graph looks like it's almost going straight up, it doesn't. It never goes straight up. It actually goes out to the sides forever. So how far to the left does it go? That goes to -infinity. And then how far to the right is it going to go? It's going to go to +infinity. So basically the domain means that this graph covers everything across the x-axis. And that's it for the distributed practice. So hopefully you use this too to help you do better on your test.